Imagine holding a lump of metal the size of a baseball. It looks ordinary, dull gray, surprisingly heavy, but otherwise unremarkable. Now imagine that this one small lump contains enough energy to power an entire city for months, or level it in seconds. That metal is uranium, and it's the most powerful element on Earth not because it's rare, not because it's radioactive, but because of what happens when you split it apart. What makes one element different from another? The answer is in the nucleus, the tiny core at the center of every atom. The nucleus is made of protons and neutrons packed together incredibly tightly. Hydrogen has one proton, carbon has 6, iron has 26. Uranium has 92 protons, making it one of the heaviest naturally occurring elements on the periodic table. When you pack that many protons and neutrons into a single nucleus, something strange starts to happen. The nucleus becomes unstable. Think of it like stacking blocks. The higher you stack, the wobblier the tower gets. Uranium's nucleus is wobbling. It's on the edge of falling apart. And that instability is exactly what makes it so powerful. Uranium atoms are naturally radioactive. Over millions of years, they slowly decay, breaking down into lighter elements and releasing tiny bits of energy as they do. But that's not what makes uranium special. What makes it special is that under the right conditions, you don't have to wait millions of years. You can make it release all that energy at once. Here's how. When a uranium nucleus absorbs a neutron, it becomes so unstable that it splits in two. This process is called nuclear fission. And when that atom splits, three things happen almost instantly. First, it breaks into two smaller atoms. Second, it releases 2 or 3 extra neutrons. And third, it releases a massive burst of energy. That energy comes from something Einstein discovered. Mass can be converted into energy. The pieces left over after the split weigh slightly less than the original uranium atom. That missing mass didn't just disappear. It became energy. And because of Einstein's famous equation, even a tiny amount of mass releases an enormous amount of energy. But here's where uranium becomes truly extraordinary. Remember those extra neutrons that flew out when the atom split? Those neutrons can hit other nearby uranium atoms, causing them to split too. Each of those releases more neutrons, which hit even more atoms. This is called a chain reaction. One split becomes 2, 2 becomes 4, 4 becomes 8. In less than a millionth of a second, billions of atoms are splitting. If this happens uncontrolled, the energy is released all at once. That's an atomic bomb. The first one ever used released energy equivalent to 15,000 tons of TNT from a sphere of uranium the size of a softball. But if you control the reaction, slowing it down so only a steady number of atoms split at any given moment, you get a nuclear reactor. The same process, but gradual and sustained. That heat boils water, the steam spins turbines, and you generate electricity. So why uranium? Why not carbon or iron or gold? Because lighter elements don't have enough neutrons and protons to sustain a chain reaction. When you try to split them, they don't release enough extra neutrons to keep the process going. Uranium is right at the edge, heavy enough to be unstable, but common enough to actually find and use. It's the sweet spot, and here's something most people don't realize. Not all uranium works the same way. Natural uranium comes in two types. Uranium-238, which makes up over 99% of it, is relatively stable. It won't sustain a chain reaction easily. But uranium-235, which makes up less than 1%, splits much more easily. To build a reactor or a bomb, you have to separate out the uranium-235 from the much more common uranium-238. That process, called enrichment, is incredibly difficult. It's one of the main reasons only a handful of countries have nuclear weapons. 1 kilogram of uranium-235, fully split, releases the same energy as burning 3 million kilograms of coal. That's not a typo. 3 million to 1. No chemical reaction on Earth comes close. Gasoline, wood, natural gas, they all rely on electrons shifting between atoms, releasing tiny amounts of energy. Uranium releases energy from the nucleus itself, where the forces are a million times stronger. That's why a single nuclear power plant can run on just a few tons of uranium for years, while a coal plant burns millions of tons of fuel in the same time. It's why nuclear submarines can travel underwater for months without refueling. And it's why nuclear weapons changed warfare forever. But uranium's power is also its danger. The same process that generates clean energy can create waste that stays radioactive for thousands of years. The same chain reaction that lights up cities can destroy them. Uranium doesn't care how you use it. It just obeys the laws of physics. So when you hear that uranium is the most powerful element on Earth, it's not because it glows in the dark or melts through steel. It's because inside every single atom is a nucleus so tightly packed, so unstable, that when you nudge it just right, it releases the energy that holds matter itself together. And there is no force in nature more powerful than that.